Good evening, all of you. Welcome, you guys. Good evening, all of you. Welcome, you guys. Welcome, welcome to the Unacademy, India's largest online education platform. Yes, first of all, please do confirm is the audio video is clear to all of you. First of all, do confirm it is the audio video is clear to everybody. Are you facing any problems? Yes, first of all, you tell me now here. So I hope it is everybody clear to all of you. Audio video is clear. Fine. Chalo. Now let's continue our discussions. So here we have small announcement from Unacademy, and we are starting a new series that is Pado Kelo Cracker. So we can so here we'll learn the concept like just a playing, and we'll play with the subject, and we have to achieve it with the top educators of India you can find. So we are starting the series from the July 1st on to August 15th. Okay, so you can follow this, you can follow the link given in the description. You do follow that link, so you will get the regular updates. And and you can find the link here. So these are the my digital circuit series. In this link you will get the complete, in this link you will get the all the practice questions and DPP assignments I have discussed, and this link given in the description, and you do follow this link, you will get my all my free classes are available in the Unacademy. And we are starting the new batches from June 29th onward. We have started with the top educators of India you can find. I started the digital in the both in Hindi and English, and the timings are 3:45 p.m. You can follow this course. And from July 13th onwards, I'm going to start the signals and systems, and you can do follow this course also from July 13th. From this month 13th onward, we are starting the signals. You can find these batches, and the students who are willing for this Unacademy subscriptions and all, they can use a code of BV Reddy to get the great discount. Where the great offers great discount, you can see. You can use a code of BV Reddy. And the target batches. And so with the Unacademy Plus subscription, you will get the top educators, doubt solving, study notes, test series is available. And in addition to this, iconic students will get additional benefits of physical notes milega, one-to-one mentorships, and study and study program, and live interaction with the educators. Right. So the students, and one more new offer here. So for this iconic subscription, so you will get additionally 4 months additional benefit आपको मिलने वाला. To avail this great opportunity, you can use a code of BV Reddy. You can use a code of BV Reddy to avail this great opportunity. Fine. Let's continue our discussion. Right. Yes, last class, how many problems we have completed? Tell me. Last class, how many problems we have finished? last class, I think we have completed the 92. We have right. So, chaliye, let's continue 93 onwards. 92 finish it now. Tell me. Yesterday, some because of some little bit of disturbances, we have wind up the sessions, isn't it? Now, let's continue our discussion. 92 problem completed. Everybody, take the 92 problem. All of you, done. All of you. So 92 problem में कोई doubt हुआ तो बोलो. Any doubt in the 92 problems? चलो, let's continue our discussions. Yes. Yeah, 2 amperes. So चलो next problem 93. In the circuit shown below, the initial capacitor voltage is given as a 4 volts. Initial value of a capacitor is given as 4 volts. The switch S1 is closed at T is equal to 0. The charge lost by the capacitor from 20 microseconds to 100 microseconds. So they has given the problem itself. Initial value to diya na here. So VC of 0 minus. How much this value given as a 4 volts. And what about the VC of infinity? What about the VC of infinity? 0. Why? Because source free circuit. VC of infinity which is equal to 0. So since it is a source free circuit now, there is no source present after the switching actions. Right now, whatever tau you tell me, tau, which is equal to RC. So this means what we'll get here, which is equal to 25 micro. 25 micro, right? Next. So let's write the expression now here. So that is VC of t, which is given as 4 into e power minus t by tau. So that is t by, so 25 microseconds. This is my VC of t, right? Now we need to find the value of q, where q is equal to c into v. So let's find the q now here, which is equal to c value given as a 5 micro. So which is given as 20 into e power minus t by 25 microcoulombs. Now we need to find the charge lost by the capacitor from 25 to 100. So if I call this as at T1, 25 is a Q1, how much will get now here? 20 into e power minus 1 microcoulombs, isn't it? Simplify how much this value? And the Q2 charge at 100 micro. How much you tell me now here? 100 into e power minus 4 microcoulombs now. Tell me how much it is. So how much is Q1 values? How much the Q2 values? Hmm? Yes. Q1 value which will get as 7.35 micro. Check it all of you. And Q2 value 0.36 microcoulombs. Right. So that means the change in charge, lost charge, I can say this is the delta Q, which is equal to, so Q1 minus Q2. So how much you will get, you tell me? It is 6.99 microcoulombs. This is the lost charge now, nearly 7 micro. Then The current I of t shown in the figure is passed through 1 farad capacitor that has zero initial charge. The voltage across the capacitor for t greater than 2 seconds is. Yes, you can do that. What I told you now. Laplace is the ultimate method. You know, Laplace is the ultimate method. But the thing is, so Laplace, when we can use this thing, Laplace, हमने discuss किया ना. Laplace is the ultimate method. So here हम, so आपने, so ब्रह्मास्त्र कब use करेगा? The Laplace is like a ब्रह्मास्त्र. When we use the ब्रह्मास्त्र, yes, बाकी अस्त्र काम नहीं किया तो तभी हम ब्रह्मास्त्र use करेगा. Exactly same thing. Yes, Laplace is the ultimate method that is applicable for any problem. You can do that by using Laplace. Yes. Fine, you can practice. You can do it. Good. Right? Now, try this problem here. The current I of t shown in figure is passed through 1 farads. Laplace method. Okay, you want the Laplace method, this thing here? So fine. So whether you all of you copy this thing here, all of you copy this thing. Right. Now, same thing here, Laplace method. So here, let us draw the circuit for t greater than 0. T greater than 0. So how the scenario, tell me now here? The capacitor has initial charge. How much the initial charge of the capacitor they given? Initial, and here this is 5 ohms. Initial voltage which is given as a 4 volts, and this is 4 microfarads. Right. Let us convert into Laplace domain here. Let us convert into Laplace domain. So I can say this is 4 by S, and this is 1 by 4 CS, and this is R. So you tell me now here, I need what I need now here? The charge lost by the capacitor. That means I need, if I know the voltage across capacitor, from this we can get the charge, we can get it now. So here, can I get the voltage across the capacitor, you tell me? If I call this is V of S. Tell me V of S, you tell me. V of S is the voltage across capacitor. Now you see this thing. This is the resistor. This also resistor only. Yes or no? So after converting this as a 1 by 4S micro, of course. So here, and the units are what you tell me now here? Ohms na? That is a resistor only. So tell me what we can say here. 1 by 4S VDR we can apply. That is 5 plus 1 by 4S. Isn't it? Tell me. Right. So that means what, can you tell me what I'll get the V of S here? Can you tell me what I will get the V of S here? Of course, here it is micro here. So it will be 10 power 6 will come to numerator. Here also 10 power 6 here. And here also this is, I can say 10 power 6. So that is V of S, which is equal to what we'll get now, 10 power 6 in the numerator, which is equal to 20S plus 10 power 6. Take it all of you. Right. So that means this is my V of T. So this is my V of S. So that is 10 power 6 by, if I have taken 20 common, that is S plus 10 power 6 by 20. So can you find the inverse Laplace of this thing V of T? So this is 10 power 6 by 20 into e power minus 10 power 6 by 20 t will come now. Check it all of you, isn't it? So now simplify this thing. So this is my V of t if you see carefully. This is my voltage across the capacitor, isn't it? This is the V of t. So then simplify it. That what we got it now previously. You see this thing here. If you do simplify, ये same आएगा कि नहीं check करो आपको. Now, so from this, what I can say, this is my voltage. Now we can get the charge Q. Q is equal to C into V of t. So what I will get now here, C value, how much the capacitance value? 4 micro. 4 into 10 power minus 6 into 10 power 6 by 20 into e power minus 10 power 6 by 20 into t. So that is q, which is equal to 10 power 6 will get cancelled. How much will get now? 1 by 5 na something. 1 by 5 something will get, you see. Yes, what we got previously, 4 something we got na. 20. Why we didn't get like that? 4 by 20 I check it. See what we got the chart. This thing 20 into I ना. इधर कुछ अलग आ रहा हमको. और एक बार. Yes, 1 second here. Fine. So here, let us see this thing here. T greater than 0. Here, let me see here. I think so. कुछ calculation गड़बड़ किया हमने. Check करो. We are doing the problem again. What? Voltage region forget to multiply with 4. Yeah. So this type of things will happen. Na? Yeah. So that's why. Okay. So here, this is silly mistake happened. So fine. Let us see this thing here. 4 by S. And this is 1 by 5. 5 microna here. 1 by 5. Yes. Into 10 power 6. Now find the voltage across the capacitor. This is V of S. Yes. So that's right. Here we can say here. Now this is 10 power 6 by 5S by. Tell me now here what we'll get now here. This is 5 plus 10 power 6 by 5S. Isn't it? Into 4 by S. So then V of S. Simplify it here. So what I will get, you tell me now here. This is 10 power 6 by, so this is 25s plus 10 power 6 into 4 by s. Check it all of you. This is my V of s. Okay. Now, so this is V of s, which is given as, that is 4 into 10 power 6 by, this is s into 25 we have taken common, that is s plus 10 power 6 by 25 into s आया. सेकंड ना हमको और एक s मिल रहा, सही ना. So that means we have to do the partial fractions here. Yeah, so this is very lengthy हो जाएगा ना. We do partial fractions. So that means a by s plus b by s plus 10 power 6 by 25. Let's find the a and b values. That's what we told. So by doing the Laplace transform will get, but the problem is lengthy ho jayega. So can you tell me how much is value of a, which is equal to 4 into 10 power 6 by s is equal to 0, means what we'll get here? This is 25 into 10 power 6 by 25. So which is equal to 4 na? B. So what about the B, you tell me? So that is 4 into 10 power 6 by s is equal to, we can replace it as, which is equal to 25 into here minus 10 power 6 by 25. Then which will get it as a minus 4. So that means this V of s, which is equal to 4, we have taken common. Then it is 1 by s minus 1 by s plus 10 power 4 by 25, isn't it? So now this total voltage, if I call, this is the capacitor voltage here, VC. Tell me now VC here, VC of S, which is given as sum of these two voltages. Now tell me VC of S, which is equal to Vs plus 4 by S, sum of these two. By adding these two here, what happens, you tell me? So how much you will get? A value how much? B value? You got the same thing or not? Tell me first of all, everybody. So here VC of S, which is equal to, adding these two here, simplify. तो हमको क्या मिलेगा इधर? This voltage Vs. Now we write the KVL now here. What we can say now, VC means what here? VC means whole voltage, is equal to minus Vs minus 4 by S plus VC of S, which is equal to 0. So that means VC of S is equal to 4 by S plus Vs. Check it all of you. And I think A we should get minus 4 here. Check it. A we need to get minus 4. Hmm? B value, we got it. Yeah, it is a very lengthy, the things will happen like that. A will get minus 4. Something I think so. Yeah, check it now. A value will get minus 4. So finally, VC of S, if we simplify, and you may get it as this thing, that is 4 into e power minus 10 power 6 by 25 into t, like this, like what we have got it, isn't it? Yes. So here I think CA we should get minus 4, something we need to get, isn't it? You see the way. So basically if you do like this Laplace is a ultimate method. The problem is it's a very lengthy compared to the regular method. So we can use a Laplace only. Yes, exactly. That's what we did. So then, yeah, the other way we can find the current and then do integrate. Yeah, that is also we can do it. Then, chalo next problem. The current I of t shown in the figure is passed through a 1 farads Right, they are asking to find the voltage across a capacitor for t greater than 0. Tell me. I'm drawing here. Right, so this is 1 and 2, this is the time, and so here we need the voltage V of t, which is given an initial value Vc of 0 minus initial value 0 given na. What's the initial value given? Initial value V of 0 plus 1 by c into integration of I of t into dt. This is my voltage, right? So that is V of t initial value to 0, which is equal to 1 by 1 integration of this signal, integration of this current, integration of this step signal now here, which will be given as what you tell me now, RAM. Integration of a step is what you tell me now, which is a RAM signal like this. And the amplitude of the step is nothing but what we can say here, slope of this line. Amplitude is nothing but slope here. You can see this thing here. So here with a what slope it will do here, this is up to 0 to 122 like this. So having a slope which is equal to plus 8. Amplitude is like a slope. Amplitude will become like a slope here. So this amplitude is 8. Then after that it will maintain a constant value. Constant value will maintain. All of you tell me. So they asked him to find the voltage across a capacitor for t greater than 0. For t greater than 0, how much is voltage you tell me? Which is equal to always, sorry, 8 volts na constant value. All of you tell me, isn't it? Done? So generally the students, there's a chance to commit a mistake here. They'll treat this as a 1. So then the signal is up to 0 to 1 only na, 0 to 1 to 2 only na. After that it is taking the 0. But here after integration this value maintain constant if you observe carefully. Integration which will be a constant, isn't it? Any doubt in this thing, tell me. If we have any doubt in this thing, so let us elaborate more this thing. अगर कोई doubt हुआ तो इसमें. Done? Shall we move to the next one? और अगर कोई doubt हुआ तो बोलिए इसमें. नहीं ना? बोला जल्दी जल्दी फटाफट, don't waste the time. A constant output. It's a constant output. Yes? Clear now? No doubt on this problem? No doubt. So we'll move to the next problem. After 2 seconds, it is constant output. Now take the next problem. The voltage V of t shown in the figure below is applied to the given circuit V of t equal to 3 volts for t less than and 6 volts for t greater than. The value of the current at t is equal to 1 second is, right? You can see. Now for t equal to 0 minus, t equal to 0 minus, so what happens you tell me? Yes, the supply How much is the supply DC voltage only, which is equal to 3 volts is the supply. And here we have 1. Inductor is shorted. Steady state. So I can say this current as IL of 0 minus. So let's find the IL of 0 minus. So let's find the equivalent resistance here, R equivalent, which could be given as these two are parallel 1 by 2, 1. So which is equal to 3 by 2. 3 by 2. Now, so I can say this current, which is equal to 2 amps. And this current is 2 amps, means IL of 0 minus is equal to 1 amp. IL of 0 minus, which is equal to 1 amp. Next, as t tends to infinity, can you find the values now here? T tends to infinity, draw the network. Same network, the only thing is what we can see. Now, instead of a 3 volts, now it is a 6 volts. Right. Now, this is 1 and this is 1. Same thing now here. Again, this R equivalent, I can say this as a 3 by 2 ohms. Right. Next. So we need this current only now, this current which we can call IL of infinity. Let's find this IL of infinity. So what will get this IL of infinity? So IL of infinity. How much will get this IL of infinity? Tell me here. Now this is 3 by 2 means how much this current here? In these cases. After t greater than 0. So this is t tends to infinity. Now here we are not finding t is equal to 0 plus. We are finding for t tends to infinity we are doing, isn't it? We are doing the t tends to infinity we are doing. Okay. So now here, how much this current here basically? How much this current here, which is equal to, that is 6 by 3 by 2. So which is equal to 4 amps. Here this is the 4 amps. Now, so IL of infinity which is equal to 2 amps. Right? Now, find out the tau you tell me. Tau is equal to L by R. So this is 1.5 by R equivalent you see. How much it is now here, which is equal to 1.5. So which is equal to 1 second. 1 second. So now, so tell me the expression here. So what is the expression here? Now this IL of t, which is given as 2 minus e power minus t hoga na. Now they asking to find, what they asking to find here? The current at t is equal to 1 second. The current at t equal to 1 second. Find out this thing here. IL of t at t equal to 1 second is equal to 2 minus e power minus 1. 1.63 amps. Done. Next. In the circuit shown, the switch is thrown from position A to position B at t is equal to 0. The energy taken from 3 volt source, the energy taken from 3 volt source to charge the capacitor from 0 to 3 volts. The energy taken from the 3 volt source to charge the capacitor from 0 volts to 3 volts. Yes, try this problem. Now, you can see now here initial value of a capacitor. Initially, the switch is at position A, right? So from this, we can say VC of 0 minus. VC of 0 minus, which is equal to what you tell me now here? 3 volts, isn't it? And VC of infinity, which is equal to 0, isn't it? Yes, infinity means the switch. Check now here. Sorry, उल्टा हो गया क्या? See the connections I didn't observe here. Initially switch is at position A. So that means here VC of 0 minus, which is equal to 0 volts now. VC of infinity, which is equal to 3 volts. Isn't it? Reverse the given. So I thought this is A. So this is B and this is A. And whatever the tau you tell me, tau equal to RC, how much will get now here? That is 12 micro. That is 12 into 10 power minus 6. So that means VC of t, which is given as 3 minus 3 into e power minus t by 12, t by 12 micro, right? Now what they asking now here? They asking for the energy taken from the source. The energy, yes, how much energy? When we have given this, you see this thing here. If I call this current is I of t, let us find this current now here. Same current will pass over via capacitor. So this current I can say this IC of t also, which is equal to C into dVc of t by dt. So find out this current IC of t, which is given as C. So that is 10 power minus 7, isn't it? 10 power minus 7, and which is equal to, yeah, plus 3 by, that is 12 into 10 power minus 6 into e power minus t by 12 micro. So tell me now here how much will get IC of t. So how much you will get the IC of t here? That is 1 by 40 into e power minus t by 12 micro. Check it all of you. This is my IC of t. Now they are asking to find the energy across the capacitor. We need to find out. Tell me now here energy. So here if you see here this is my source. The source is giving the energy to capacitor to charge this thing here. The energy across given by taken by this capacitor, but we are giving the energy, and this resistor also will take the energy. Na? Resistor will keep on will dissipate the energy, right? So directly I cannot apply this energy to my capacitor. In the process of charging my capacitor, some of the energy will be dissipated across the resistor. So that means what they asking here, what they asking the problem, the energy taken from 3 volt source. How much? That means energy given by the 3 volt source to charge the capacitor. Yes or no? How much the energy given by the source to charge? In the process of charging the capacitor, some of the energy will get wasted across a resistor. So what we know here, that means we need to find the energy across resistor as well as energy across capacitor. Energy across resistor as well as energy across capacitor, both we need to find, right? So, and what we can do here, instead of finding the energy across resistor and capacitor, I can find the energy delivered by my source. The energy delivered must be equal to energy absorbed. So this resistor will absorb and capacitor also will absorb. Instead of finding the energy across a resistor and capacitor both, I'm just finding the energy given by my source. If I find the energy given by my source is nothing but energy taken by the resistor and inductor hoga na? Energy given must be equal to energy taken, isn't it? So that's what we are going to do here. So that means, so let us find the power across my source, which is given as what to tell me? Voltage is 3. So which we can say 3 into IC of T. Check it all of you. This is the power across my source. So that means P of T, which is given as IC of T, that is 3 by 40 into e power minus T by 12 micro. So from this energy given by the source, which we can say from steady state 0 to infinity, yes, is equal to 3 by 40 into e power minus T by 12 micro into dt. And simplify, get this value 3 by 40 into e power minus T by 12 micro by minus 1 by 12 micro. Limit 0 to infinity. तो फ्रॉम दिस फाइंड आउट द एनर्जी हमको कितना मिलेगा तो 3/40 into 12 micro. So that is how much this energy will get, you tell me? That is 0.9 microjoules. Check it all of you. Right. And if you observe carefully in this problem, so most of the students might commit a mistake for the option B, isn't it? So the chance to go for this option B, that is 0.45 microjoules. The 0.45 microjoules option B, that is energy across capacitor only. Energy across capacitor. But thing is, you need to observe while doing the process of charging my capacitor, some of the energy get wasted. Some energy get wasted, right? That energy also we have to find out. Okay, then next one, the damping ratio of series RLC circuit can be expressed as damping ratio of a series RLC circuit. The damping ratio of a series RLC circuit, if we remembered, which is equal to damping ratio, so zeta, which is given as R by 2 into square root of C by L. R by 2 into square root of C by L. Right? Now you do remember this thing as we know here. Zeta into quality factor, which is equal to 1 by 2. Did you remember it? Zeta into Q equal to 1 by 2. This is also one important relations. Try to remember. In the given circuit shown, the switch is closed at t is equal to 0. Assuming 0 initial conditions, the value of voltage across 2 ohm. damping ratio, this output and input he didn't mention. So this is okay. So we can assume the series circuit now. Series circuit he didn't mention, but he didn't mention where has taken the output here. He didn't mention. So in general, what we have taken here is a voltage is a input, current is a output. In this case, we have taken it as voltage is a input and current is a output. IFT, right? Voltage, and voltage is a DC voltage and current is output. In the given circuit shown, the switch is closed at t equal to 0. Assuming initial condition, 0 initial conditions, the voltage, the value of voltage across a 2 ohm resistor is, where is 2 ohm here? Okay, and t is equal to 1 second. Now the switch is closed at t equal to 0. Yes, initially the values are zeros, right? So that is Vc of 0 minus, which is equal to 0 volts. And what about the Vc of infinity? Vc of infinity, which is equal to 2 by 5 into 10, isn't it? Which is equal to 4 volts. And what about tau? Tau is equal to here, that is 6 by 5 into 5 by 6, which is equal to 1 second. So from this, what we can write now here, Vc of t, voltage across capacitor, which is equal to 4 minus 4 into e power minus t. This is the voltage across capacitor, right? We need at t is equal to 1 second. So that means Vc of t equal to 1 second is equal to 4 minus 4 into e power minus 1. How much it is? 2.528. Next, the circuit shown, the initial voltage across the capacitor C1, C2 are 1 volt and 3 volts respectively. The switch is closed at T is equal to 0. The total energy dissipated in the resistor until steady state is reached is, right. The total energy dissipated means which element will dissipate the energy, which element will dissipate the energy, only resistor will do this thing. So to find the energy dissipated, we have to get the current here. If I know the current here, I can get the energy across the resistor. Done. So let's simplify it here. And here we can go for the Laplace now. So here we will go for the Laplace domain. Right, and this is 10 and C2, which is equal to, this is 1 by 3s, and here this is, and 3 by s. This is 3 by s. This is 1 by 3s. Now it is in ohms, and which is equal to 1 by s. This is also 1 by s. Let us find the current I of s. Now tell me now here I of s. I of s. Tell me here, which is equal to 3 by s minus 1 by s by, right, 10 plus 1 by s plus 1 by 3s, right? Let's find what way there. Why to use Laplace, you are asking? So here, without using Laplace, how we can get the current, you tell me? I need the current in the loop, we need to get it now here. So this capacitor, which is in the farads, and this is the ohms now here. So we need to get the common thing required now. Capacitors ko we need to convert in terms of resistance. Then only we can get the current. Right. So how much you will get, you tell me now here, which is equal to 2 by s by, and simplify, how much will get? That is 3 by, so which is equal to 15 s plus 2. Check it now here. This is my current. Yes. So then I of s, which is equal to, that is 3 by, yes, doing that method is very lengthy. Yeah? Doing that method is very lengthy. If you want, you can check that one. So if we write the initial values, but we cannot get the current now, how we can get initial values? So here you see this thing here, fine. So here I have replaced it with the initial values. Then I have replaced with the initial values only. Then you tell me what you want to do, how we can get the current. Replace with the initial values only. So here this is my 10, and so here this is the 3 volts, and here we have a 3 farads. This is 1 volt, and this is 1 farad. Now you tell me, I need this current now. Tell me what you will do. How we can get I of t? Tell me. How we can get this I of t? What we can do? Tell me. So that means, so finally, what I will get now? I of t, which is equal to 3 by 15. Yes, into e power minus of 2 by 15 into t. Take this thing here. This is my I of t. So what they asking, you tell me? Energy dissipated. So energy dissipated, so that means what we can say, energy which is given as integration of p of t into dt, from where to where? 0 to infinity. Steady state now. Yes, simplify, it is now here p of t. How much this value you got, to tell me now here. Check this current expression. So this is wrong, I think so. Here is, this expression is correct? How much you got the current? Is this value correct? 1 by 5 something, na? Correct only, isn't it? Fine. Now, so what should be now here, which is equal to, from 0 to infinity, which is equal to 9 by 225, isn't it? Into e power minus 4 by 15 into t into dt. Tell me now here, this is 9 by 225 into e power minus 4 by 15 into minus 4 by 15. That is 0 to infinity. Simplify and get it. How much will get an answer? Tell me. What's the answer? Hmm. How much is answer? Exponential? How much? Okay, resistance is there. Now, how much resistance value? 10. Okay. So we should multiply with the 10, say we should multiply I square into R. I square into R now. So this is P of T. Is I of T square into R. 15 square only 225, yeah? 15 square only 225. Yeah, this exponential what will do? So this is this 2 cos square. This is 2 cos square. Okay, this is square na. Okay, you meant to say this thing na. Okay, 15 square. Okay, this thing. Now the 15 square means 225 and simplify how much will get? So this is 1.5 joules. Take it. Take this answer. So check the values should be 1.5. But yeah, 1.5 is answer. Take it. 0.5 is answer. Three of t. So this is energy, which is given as integral 0 to infinity. So I square of t into dt is given as 0 to infinity, which is equal to 9 by 225. So this is e power. Aryan, why 225? Why 4 by 15 only na? यार निशांक क्या हो क्या बोल रही है पूरा घर खराब किया yes what is this thing here so this is a power m into n which is equal to a power mn ना क्या हो गया आपको this is 0 to infinity e power minus 4 by 15 t into dt so this is 9 by 225 into e power minus 4 by 15 t by minus 4 by 15 and limits are 0 to infinity is equal to how much simplify this thing here we'll get 1.5 joules Next, say the next problem. A series RL circuit is excited at t is equal to 0 by closing a switch. At t is equal to 0, switch has been closed. Okay. They are asking to find d square I by dt square. So let's find the initial values and final values. So which we can say initial values. What we'll get now here, IL of 0 minus, which is equal to 0, and IL of infinity, which is equal to V by R. Now, so this is IL of t, which is given as V by R minus V by R into e power minus t by tau. Tau is equal to L by R. So, what I will get, you tell me? So, which is equal to, this is R by L into t. We need the, so 2 times differentiation, d IL of t by dt. So first time if I do here, that is minus V by R plus R by L into e power minus of R by L into t. Now d square IL of t by dt square. Again differentiation. So then V by L into minus R by L into e power minus of R by L into t, which is equal to minus VR by L square into e power minus of R by L into t. Replace t is equal to 0. Replace t is equal to 0, then what I will get, you tell me? D square I of 0 plus by dt square, which is equal to minus VR by L square. Done? Fine. Yes. So option D. Yeah. Finally, we have reached the century. हमने complete किया. We have completed 100 problems. We have finished. Right. So fine. And we have many problems. We need to do it. Hello. Yes. That's for the today's class, and we'll meet in the next class.